In a revelation that has sent ripples through the scientific community, the James Webb Space Telescope has detected an enigmatic signal from a distant exoplanet, 4.2 light-years from Earth. This extraordinary finding, a series of rhythmic, infrared pulses emanating from the surface of a rocky world orbiting a nearby star, has ignited fervent debate about the possibility of advanced extraterrestrial civilizations. The telescope, humanity's most advanced eye on the cosmos, was trained on a planet known as Gliese 581g, a super-Earth nestled in the habitable zone of its red dwarf star. What it found was unlike anything astronomers had seen before, a pattern of light that flickered in a way that seemed almost deliberate, as if crafted by an intelligence far beyond our own. Could this be the first tangible evidence of a technological society thriving in the vastness of space? The implications are staggering, and researchers across the globe are racing to understand what these signals might mean. The discovery began during a routine observation cycle, as the JWST's infrared sensors scan the Gliese 581 system. Unlike typical planetary observations, which reveal steady thermal emissions or reflected starlight, the telescope recorded something peculiar, a sequence of infrared bursts pulsing at regular intervals. These were not the chaotic flares of volcanic activity or the random glints of icy surfaces. The pulses followed a mathematical rhythm, almost like a beacon, repeating every 47 minutes with uncanny precision. Scientists at NASA's Goddard Space Flight Center, where the data was first analyzed, described the moment as electrifying. "We've seen exoplanets emit infrared before," said Dr. Elena Martinez, lead astrophysicist on the project. But this was different. It's as if the planet is signaling something, and we're just beginning to decode it. Gliese 581g, roughly twice the size of Earth, orbits its star at a distance that places it squarely in the so-called Goldilocks zone, where liquid water could exist. This alone makes it a prime candidate for habitability studies. But the rhythmic pulses add a layer of mystery. Natural phenomena, like stellar flares or atmospheric storms, rarely produce such consistent patterns. The JWST's ability to capture infrared light with unprecedented clarity allowed it to isolate these signals from the background noise of the star's radiation. The telescope's 18 gold-coated mirrors, cooled to near absolute zero, are designed to detect the faintest traces of heat and light from distant worlds. In this case, they revealed a phenomenon that defies conventional explanations. The scientific community is abuzz with theories. Some propose that the pulses could be the result of exotic geological processes, perhaps crystalline structures on the planet's surface reflecting starlight in a unique way. Others suggest a more radical possibility, that these signals are techno-signatures, evidence of an advanced civilization manipulating energy on a planetary scale. The idea is not as far-fetched as it might seem. For decades, astronomers have searched for signs of intelligent life, from radio waves to artificial heat signatures. The JWST, with its unparalleled sensitivity, is uniquely equipped to detect such clues. Its mid-infrared instrument, capable of analyzing thermal emissions, can pick up subtle variations that older telescopes would miss. If these pulses are indeed artificial, they could represent a civilization harnessing energy in ways we can scarcely imagine. To understand the significance of this discovery, it's worth stepping back to consider the capabilities of the JWST. Launched in December 2021, this marvel of engineering orbits 1,000,000 miles from Earth at the second Lagrange point, a stable spot where it can observe the cosmos without interference from our planet's atmosphere. Its primary mirror, spanning 21 feet, collects light from the universe's most distant reaches, allowing scientists to peer back to the dawn of galaxies. But its true power lies in its infrared capabilities. Unlike visible light, which is easily scattered by cosmic dust, infrared can penetrate these clouds, revealing hidden worlds. For exoplanets like Gliese 581g, this means the JWST can study not just their surfaces but their atmospheres, searching for signs of habitability or even technology. The pulses from Gliese 581g have prompted a flurry of follow-up observations. Astronomers are using the JWST to map the planet's surface, looking for clues about its composition. Preliminary data suggests that Gliese 581g has a rocky terrain, possibly dotted with vast metallic or crystalline structures that could account for the reflective pulses. These structures, if natural, might be unlike anything found in our solar system. If artificial, they could indicate a civilization capable of engineering on a planetary scale. The planet's orbit, which takes about 32 Earth days, allows the JWST to observe both its day and night sides. During the night side observations, the pulses remain consistent, ruling out simple reflection of starlight as the sole cause. One intriguing hypothesis is that these pulses could be the result of massive energy collectors, perhaps akin to solar panels or Dyson structures, designed to capture the star's energy. Such technology would imply a civilization far more advanced than our own, capable of manipulating resources on an enormous scale. The JWST spectrograph has begun analyzing the planet's atmosphere, searching for chemical signatures that might hint at industrial activity. Gases like chlorofluorocarbons or nitrogen oxides, which are rare in natural settings, could suggest technological processes. So far, the data is inconclusive, but the presence of water vapor and methane, key ingredients for life, has been confirmed, fueling speculation about the planet's potential to support biology. The discovery has also reignited interest in the search for extraterrestrial intelligence, SETI. Founded in 1984, SETI has long relied on radio telescopes, like the Allen Telescope Array in California, to listen for signals from distant stars. Radio waves are ideal for long-distance communication, as they travel vast distances with minimal distortion. However, the Gliese 581g pulses are in the infrared spectrum, a medium less commonly associated with communication but potentially more efficient for signaling across light years. SETI researchers are now collaborating with JWST teams to determine whether these pulses could be an intentional signal, perhaps a beacon meant to attract attention. The mathematical precision of the 47-minute cycle has led some to speculate that it could encode information, though decoding it remains a daunting challenge. Skeptics caution against jumping to conclusions. Dr. Rajesh Patel, an exoplanet researcher at Caltech, points out that natural phenomena can mimic artificial signals. We've seen pulsars emit regular radio bursts that we once thought might be alien signals, he notes. These infrared pulses could be caused by a radiological process we don't yet understand. To test this, scientists are comparing the Gliese 581g data with models of known planetary behaviors. For example, planets with thin atmospheres can experience extreme temperature swings, causing surface materials to expand and contract in ways that might produce reflective pulses. However, the consistency of the signal challenges these explanations, as natural processes rarely maintain such precision over time. The JWST's role in this discovery cannot be overstated. Its ability to observe in the mid-infrared range allows it to detect heat signatures that other telescopes miss. For Gliese 581g, this means capturing emissions from the planet's night side, where temperatures drop significantly. The pulses, intriguingly, are stronger on the night side, suggesting that whatever is producing them is not solely dependent on stellar illumination. This has led to speculation about internal energy sources, perhaps geothermal or even technological. The telescope's fine guidance sensor ensures that it remains locked on the planet, even as it moves across the sky, allowing for continuous observation over multiple orbits. As scientists delve deeper, they face a critical question: how can we distinguish between natural and artificial signals? The answer lies in the details. Natural processes, like volcanic eruptions or atmospheric storms, tend to produce irregular patterns. Artificial signals, by contrast, often exhibit mathematical regularity, as seen in the Gliese 581g pulses. Researchers are now developing algorithms to analyze the signal structure, looking for patterns that might indicate a deliberate design. If the pulses follow a non-random sequence, such as a prime number pattern, it would strengthen the case for an intelligent origin. The discovery has also sparked a broader conversation about humanity's place in the universe. For centuries, we've gazed at the stars, wondering if we're alone. The possibility that Gliese 581G could host a civilization challenges our assumptions about life and technology. If confirmed, it would mark a turning point in human history, raising profound questions about our relationship with other intelligent beings. Could they be aware of us? Are they trying to communicate? The JWST's data offers no definitive answers, but it provides a tantalizing glimpse of what might be possible. To explore these questions, scientists are planning additional observations with the JWST and other instruments. The extremely large telescope, set to begin operations in 2028, will complement the JWST by analyzing exoplanet atmospheres with even greater precision. Its 39-meter mirror will collect more light than any ground-based telescope, allowing it to detect faint chemical signatures that the JWST might miss. For now, the JWST remains our best tool. Its cryogenically cooled instruments capturing data that could reshape our understanding of the cosmos. The pulses from Gliese 581G also highlight the challenges of exoplanet research. Stars like Gliese 581 are bright, often drowning out the faint light of their planets. The JWST uses a coronagraph to block starlight, allowing it to focus on the planet's emissions. This technique, akin to shielding your eyes from the sun to see a distant object, is critical for studying worlds like Gliese 581G. Future telescopes may improve on this, using star shades, massive, free-flying screens that block starlight from space, to enhance our view of exoplanets. These advancements could reveal not just pulses but detailed images of planetary surfaces, potentially showing structures or activity. Public interest in the discovery is soaring. Social media platforms, including X, are filled with discussions about Gliese 581G, with users speculating about everything from alien megacities to natural phenomena. NASA has responded by hosting webinars to explain the findings, emphasizing that while the pulses are intriguing, they are not yet proof of extraterrestrial life. The agency is also working with international partners to coordinate follow-up studies, ensuring that the data is rigorously vetted. The implications of this discovery extend beyond science. If the pulses are confirmed as artificial, they could challenge our philosophical and cultural frameworks. Religions might grapple with the existence of other intelligent beings, while governments would need to consider how to respond to potential contact. The scientific community is already preparing for these scenarios, drawing on protocols developed by SETI for handling evidence of extraterrestrial intelligence. These protocols call for transparency, international collaboration, and careful verification to avoid false positives. For now, the focus remains on gathering more data. The JWST is scheduled to conduct additional observations of Gliese 581G over the next 6 months, aiming to refine the signal's characteristics. Scientists are particularly interested in whether the pulses change over time, which could indicate dynamic activity on the planet's surface. They are also analyzing the planet's orbit to determine if the pulses correlate with specific regions, such as a fixed point on the surface. This could suggest a stationary source, like a beacon or energy facility, rather than a widespread phenomenon. The discovery has also inspired renewed investment in space exploration. Governments and private companies are eyeing the development of next-generation telescopes, capable of not just detecting signals but imaging distant planets in detail. Concepts like the Habitable Worlds Observatory, proposed by NASA, aim to search for life by studying dozens of exoplanets in the coming decades. These missions, while still in early planning, could build on the JWST's legacy, bringing us closer to answering the ultimate question: are we alone? As we await more data, the pulses from Gliese 581G serve as a reminder of the universe's vastness and mystery. Each observation brings us closer to understanding our cosmic neighbors, whether they are geological oddities or intelligent beings. The JWST, with its golden mirrors and icy instruments, is our guide in this journey, illuminating the dark corners of the cosmos. Its discoveries, like the rhythmic pulses of Gliese 581G, challenge us to expand our imagination and refine our science. The search for life beyond Earth has always been driven by curiosity and hope. From the earliest stargazers to modern astronomers, we've looked to the skies for answers. The JWST's detection of these infrared pulses is a milestone in that quest, a hint that we might not be alone. Whether the signals are natural or artificial, they remind us that the universe is full of surprises, waiting to be uncovered. As we continue to explore, we carry with us the dream of connection, not just with other worlds, but with the deeper truths of existence. This moment feels like a turning point. The pulses from Gliese 581G, captured by humanity's most advanced telescope, are a beacon of possibility. They invite us to ask bold questions, to push the boundaries of what we believe is possible. Scientists, philosophers, and dreamers alike are watching, waiting for the next piece of the puzzle. The James Webb Space Telescope, orbiting silently in the void, is our window to that future, its infrared gaze piercing the darkness. Whatever lies on Gliese 581G, be it rock, crystal, or civilization, it's a story that's only beginning to unfold.